Okay, in the previous problem, in problem 3, we talked about the differences in mass spectrums. Some are given as relative abundance versus mass, and some are given as signal intensity versus mass. Now we're going to do a couple of practice problems that look at the two different ways we can interpret the data. In this first one, we see a mass spectrum for zirconium, and it's given as relative abundance, relative percent abundance versus mass. And we're going to use this mass spectrum to determine the average atomic mass for zirconium. That average atomic mass must be justified with calculations. So try this on your own if you haven't already, and I'll spend the next couple slides going through it with you. Okay, for a percent abundance versus mass graph, which is what we have here, the average atomic mass is really straightforward. It's done using the same calculations that we've done before. We just multiply the masses of each isotope. So these are the masses 90, 91, 92, 94 by their respective relative abundance, which we can read off of the y-axis, and then add all of those together to find the average atomic mass. Okay, so we can see that zirconium has 5 isotopes. Like I had pointed out on a previous slide, one is at 90, one is at 91, one is at 92, one is at 94, and one is at 96, okay? Now their values, you just read directly, the values for their abundance, you read directly off the graph. The 90 isotope has an abundance of 50%. 91, an abundance just over the 10 here, so we call that 11. We do the same thing here. We can see these two are about the same, just below 20% at 18, and then this one is even below the halfway line here, which would be 5. So this mass 96 has an abundance of 3%. And from there, you just calculate average atomic mass like you always would. 90 times its relative abundance, 50% written as a decimal, plus 91 times its abundance, 11% written as a decimal, plus 92 times 0.18, plus 94 times 0.18, those have the same abundance, plus 96 times 0.03, 3%, and we get 91.37 AMU. And you can compare that to your mass of zirconium on your periodic table. It should be pretty close to that 91.37. I'm just looking at my AP College Board periodic table. It's 91.22. So this is a little overestimated, and that's okay, right? We're reading these directly from graphical data. So if we don't have more lines to help us more closely estimate our values, we should expect some variability.